question 9 was requested. Now, two particles of mass 6 kilograms and 8 kilograms rest on a horizontal table. The coefficient of friction between both particles and the respective tables is half. What that means is that there's going to be friction both ways. Now, the thing to remember is both particles are only going to, if they are to travel, they're going to travel one way. They're going to travel inwards this way. Now, the thing I want you to remember about shared rope is they feed it at different rates. So, for example, imagine the six kilogram one gave 10 centimeters of rope, an extra 10 centimeters here, and then the 8 kilogram one only gave, for argument's sake, 6 centimeters of rope. This is 10 plus 6 is 16. But this 16 has to be divided equally among both of them. So this would mean a drop of 8 centimeters for the central particles. Okay? Now the accelerations are the same. So, for example, it's the average of the two amounts. So if the 6 kilogram one has acceleration A, and the 8 kilogram one has acceleration B, then the acceleration of the central particle will be A plus B all over. It's good to remember that. Next thing. Okay, so what we're looking at here is show that none of the particles will move if m is smaller than or equal to. Okay, now the deal is that what happens is m was a really small value, let's say 1 kilogram. Neither one of them are going anywhere. I don't know the exact value where it starts moving, so when you eventually up it, I don't know, like let's say 6.1 kilograms. Okay, what should happen there is that this 6 kilogram one starts to move, but the 8 kilogram one stays where it is because it requires less force to move the 6 kilogram one compared to the 8 kilogram one. Okay? So what we can assume is that the 8 kilogram one doesn't move. Okay. Now it's a common tension purely because there's only one rope. Okay. Now what we're going to do is we're going to break up 6G going downwards, and we're going to have R1 going upwards. And then we're going to have friction, and friction is going to be half of 6G. Remember, friction is mu R, half of 6G, which is, for argument's sake, while we're at it, the 8 kilogram particle, although it's not moving, half of 8G, because R2 is the same as 8G. So half of mu R2 would be half of 8G, and if it was to move, it would have a friction of 4G. Okay, now that I've cleared that up, I can just get rid of the R1 there. Just keep the question intact. Now, next thing we're going to do is we're going to analyze the 6 kilogram particle. It has acceleration A. Acceleration B is 0 because it's not moving. So this means B equals 0. And the common acceleration, remember, was A plus B all over 2. Well, B is equal to 0, so its acceleration is just going to be A over 2 going down. Okay, now that we have these tricks out of the way, here's what we're going to look at. Do remember something, that none of these particles are allowed to move. So that none of the particles will move. If none of the particles are moving, this implies that A equals 0. We're going to use that later on in the question. No point in using it now, we want to use it later on. Here's what we're going to set up. We're going to first of all look at the 6 kilogram particle. 6 kilogram particle in theory would be moving to the right. It would be getting pulled by the tension and take away the friction, which is moving to the left. In theory, it should be 6A equals T minus 3G. Right. Next thing we're going to look at is the mass M here. In theory, it's going downwards, so its force is going downwards. This implies that its weight, which is capital mg, its weight is greater than 2T, 2 times the tension acting upwards. Okay? So, in a case like this, F gets replaced with capital MA. Capital MA. Now what we might do is I might multiply the top equation, which is the yellow one. I'm going to multiply that by 2. Now when I multiply that by 2, I'm going to get 12A equals 2T minus 6G. The 2 T's cancel. What I'm going to get is 12A plus capital MA equals capital MG minus G. I'm going to isolate A on its own. Then we're going to get A equals 12 plus M equals G 6. And then A on its own, bring the 12 plus M underneath. And we're going to get G into M minus 6 and 12 plus M. Now, please remember that A has to equal 0. If A equals 0, it means the numerator equals 0. Here's the part of the numerator that can be adjusted. Now, A cannot be negative because there's no option of it going backwards. 6 kilogram particle is only going to move inwards, and the M particle can only move downwards. It's not going to be a case where it's moving upwards. We know that it can't be negative, so what we know is that it won't move for M minus 6 if M minus 6 is negative. And then bring over the 6 over your side, and you get M is less than or equal to 6. Okay, and that proves what you're talking about. As you do there is you turn the A into 0. You cross multiply up, bring G underneath, and because you're multiplying by 0, you just end up with 0 is equal to M minus 6. But remember, A is going to be, sorry, that was acceleration. You want the acceleration to be negative, so it'll be less than or equal to. That's how we ended up with there. Okay, let's move on. Show that if M is equal to 12, find the acceleration of the particles and of the movable pulley in terms of G. Alright, we're going to go back to the top here. Oh, sorry guys. Can't believe I've made an error. Made one error, and oddly enough, it didn't affect my answer. Where's the mg? This is not mg, this is mg over 2. Oh, sorry, ma over 2. I'll make that mistake. Sorry lads, one mistake there. Remember I said it was a over 2 for that. So that's an a over 2. That's an a over 2. M over 2. That's an m over 2. And still doesn't affect the fact that it's m minus 6 is the numerator. So just be careful about that. That's m over 2 because the acceleration was a over 2. So just watch out for that. It doesn't actually affect the answer in the end. That's how you won't actually know if you made a mistake. So you could get the question right, but you still lose a mark or 2 for obviously making the mistake. C'est levé. Now, let's move on to the next one. Is now all of a sudden the 8 kilogram particle is moving. Okay, and its acceleration is b, moving inwards. This means the acceleration of this particle here is going to be a plus b all over 2. That's m acting downwards. I'm going to start off with the 6 kilogram mass again. Its force is going to the right, which is T take away 3G, which is going to the left. This means it's going to be 6A equals E G. Now, what does it want from me? Find the accelerations of the particles. So I have to find A I'm going to have to find b, and then I'm going to have to find a plus b over 2, all in terms of g. Okay, so I'm going to have to do that. And we know the m value is 12. That is 12g. 12. Now, we're going to do the middle particle. The middle particle, its force is going downwards. It's going to be equal to its weight going downwards minus 2 times the tension going upwards. It's going to be 12a, 12g minus 2g. I have to divide that by 2. I'd probably get a 6a equals 6g. Take away g. Okay. Next, we're on is the 8 kilogram particle. And in the 8 kilogram particle, it's moving inwards with acceleration v. Force is going to the left, and it's caused by the tension moving to the left. Take away the friction, which will be counteracting this movement by acting. Now we get force equals 8a. Tension is still T going to the left, 4g. Okay. Oh, and it's not 8a. The acceleration of the 8 kilogram particle is actually b. So it's 8b this time. Okay. So I have 3 equations here. And my job with each of these equations is to figure out the answer. Okay, so I'm going to add, let's go for equation 1 and equation 2 added together. Equation 1 plus equation 2 is 12a. The t's cancel and I get 6g take away 3g, which is just 3g. And I get a equals 3g over 12. I'm hoping that a equals g over me. And actually, oddly enough, just like last time, the exact same mistake I made in the last part. It's actually not 12a. Keep making this mistake. It's 12 times a plus b over 2. So it's actually 12 times a plus b over 2. And that's the mistake I've made twice now at this stage. So shows you it can happen anyone, anytime. So let's try this out now. 12 times, just 12 divided by 2 is 6. Made a mistake there. And multiply the 6 in, and I get 6a b 12g minus 2. Okay, now I'm at the stage where I have my 3 equations. What I'm going to do is I'm just going to get rid of everything else. That's okay. So I'm just going to get rid of everything else here. That's my bad. And to get rid of that here. Now, I got to work with the 3 of these and try and get one letter on its own, try to get A on its own, and then see how we go from there. T is the universal letter between all the sets. T is very important here. Okay. Now, what we do is we trade off T over here. We got 3 here. Question 3. Now, trying to think now. So, yeah, here's what we'll do. We'll systematically get rid of B to begin with, right? So B equals T minus 4G all over. I'm then going to plug that, which is still equation 3, I'm going to plug that into equation 2, and we're going to get 6a times b, which is 6 times t minus 4g all over 8. That equals 12g. 8. Now the thing to remember about 6/8 is 6/8 is the same as 3/4, so let's turn that into 3/4 really quickly. Now, because it's 3/4 and we have a fraction here, I'm going to have to multiply across by 4. So that's going to become 24a. This is just going to be 3t minus 12g. Multiply across by 4, I get 48g minus 8t. That's 3t. Now, what I'm going to do is I'm going to just move the g's over one side. So I'm going to get 36g. Oh, no, not 36. I'm going to get 60g. And then bring that over, minus 11t equals 24. And that's a combination of 2 and 3. Equation 2 and equation 3. Now I'm going to introduce equation 1. I'm going to do what equation 1 is. I'm going to sub out the t. T here, we can say that t equals 6a 3g. So I'm hoping it's going to be minus 11 times 6a plus 3g is 24a plus g. Now let's see what we're up to here. 24a equals 60g minus 66a minus 33g. Move it over to your side. 24 plus 66 is 90a. 90a equals 27g. And 27 divided by 90, I believe, is 3/10. Yeah, 27 divided by 90 is 3/10. So I'm looking at 3/10. Now make sure you look at your solutions when you're doing these. There we go. 10. Happy with that. It's good to spot the mistake there. Okay, now I figured out what A is. So once I figure out what A is, I need to figure out what T is, and then if I figure out what T is, I can then figure out what B is. So we know that T equals A plus 3G, which is from equation 1. 6A plus 3G. T equals 6 times 3G over 10 plus 3G. 18G over 10. 3G equals T. 18 over 10 plus 18 over 10 plus 3 is 24 over 5g. Now, trying to find out what b is. Well, we go to equation 3, we can find out that b is t minus 4g over 8. B is t minus 4g all over 8. And what we can get here is that b is 4 over 5g, take away 4g all over 8. In your calculator, just say 25, 4 over 5, take away 4 divided by 8. And it should do the answer pretty quickly. I'm about to get b equals 1/10 g. So b is 1/10 g. Once again, check your answer. G over 10, same as 1/10 g. Now finally, the last thing we need to do is we need to get the average of a plus b. So remember, we had to get a plus b over 2, I mean, the average of the m. Okay, so we know that a is 3 over 10. So it's going to be 3 over 10 over 10 divided by 2, which is going to be 4 over 10 divided by 2, which is a fifth. So g, which is 1/5 g. And once again, we just scroll down. 1/5 g. Happy days. That's everything correct, and we're fit to move on.